I just want to mention again, I haven't deleted this for my syllabus, but don't go by this. These are the chapters we're going to cover, but don't go by this for what problems to solve. I'll keep putting that in Word documents. This is from somebody else's syllabus using this book. I just wanted to mention that again. Oh, and what I've got over there on the board, those are sections in the book. Since I haven't put up a schedule yet, this is, these we won't cover today, but this is where we're going for test 2. I think test 2 will be not next Thursday, but the next Thursday. I think that's where we're going to be. And this is what I'm hoping to do today. I might not get through all of it. I want to leave a little time to show you about the take-home lab with your laptop. But so we're still in chapter 3. Oh, I did mention to you guys that I won't have those tests graded until next week. Hopefully I can do more multiple choice going forward, but when it's all math, it's just too hard to do it by multiple choice. Also, I mentioned that I wasn't going to make out balance equations. You'll have to balance equations a little bit. I'll keep them kind of simple, but balancing equations is just it's an odd skill that I feel like is kind of misplaced. But there's only one place where I feel like it's important, and I think we'll get to that today. But so 3.1 and 3.2, well, here, let's see this. So here's chapter 3. We've covered formula weights, Avogadro's number, empirical formulas and analysis, quantitative information for balanced equations. We actually did all that. That was more or less on test 1. The things we still want to do, I didn't put limiting reactants on test 1. I'll do that on test 2. So I'll hit this again and give you some problems to solve. But I want to cover a little bit about chemical equations and the patterns of reactivity. And then we'll do limiting stuff again. So maybe that helps orient you guys. So 3.1, just hitting the highlights here in this section. I've already mentioned that. Balancing equation, I'll go through a little bit of that. And the only other thing to mention from chapter 1, section 1, is these in parentheses here. So the parentheses are telling you the S here means solid. So if you're making this reaction happen and these are your reactants, this was put in as a solid, and the L means this was in the liquid state. There's also G for gas. So sometimes we rarely in the lab put gases in as our reactants because gases are difficult to manipulate. We almost always work in liquids and solids. But you can produce a gas sometimes and it just bubbles out of the solution. And aqueous means it's dissolved, meaning it's split out into its ions. So if I pointed at the NaOH here and said, okay, that's an ionic compound, it's Na plus and OH negative. Aqueous means that Na and the OH have split apart and are floating around separate from each other in the water or in the liquid. So solid, liquid, gas, and aqueous are the main things that will be in parentheses. And I think that's all that's really needed. I'll do some balancing equation examples, but this is showing balancing here. I could use that, but I'm going to go to the back of the book to do that. And then in the simple patterns of reactivity, handful of things to know. But this is very easy. So if you had a reaction like this one, let's see what I'm doing, right? Yeah. Carbon plus O2 makes CO2. So here's two things coming together as one thing. We call that a combination reaction. It's something you can see very easily. Decomposition is where you have one thing and it's splitting out into two new things. So here you have KClO3, that's one thing, one compound. And then the products are KCl and O2. So this has split apart into two pieces, so that's a decomposition reaction. And so there's those two things. I don't think there's anything else in here. Yeah, combustion. Hallmark of combustion. So you have your reactants and your products. Combustion, this is fire, this is gasoline burning, anything that you think of as burning is combustion. And the hallmark of a combustion reaction is you always, 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 always have CO2 and H2O as your products. One other thing you always have is O2 as one of the reactants. The only thing that varies in a combustion reaction is this molecule. Combustion pretty much always happens with carbon and hydrogen, what we call hydrocarbons. So you see here, what is that, C3H8 in this example. So you'll see C and you'll see H in the reactant there. You will sometimes see some oxygen there. So it can be, it's almost always just C and H, but sometimes there'll be C, H, and then some oxygen. You can also do combustion with nitrogen in that compound as well, which makes N2 show up on the right side. But I don't think your book uses any of those examples. So just think of it as carbon, a hydrocarbon, but it might have a little oxygen on it too. These can get very sticky to balance, so I'll keep those simple too. Don't put anything like that on the test. Okay, combustion, so it's combination reactions, decomposition reactions, combustion, and I guess they wait until the next chapter to talk about precipitation reactions, but I think I'll get to those today. I have some Word docs that I'll upload that'll tell you which of these exercises to do. I've got a list here though. So some like 311. So this will be some balancing. I'll leave this one because that's got the answers to it. I don't think any of these are too hard. But let's look at, I'm going to look at these. 312. So the reason I don't like doing balancing is because it's an iteration. It's not, you set up a formula and you go bang, 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 and you do your algebra and then there's the answer. It's an iteration, which is kind of strange, but which is why I don't like to do it, because it just feels weird. It feels unwieldy. It's almost like you solve it by trial and error. So Li into, so Li, I guess I'll put these in, LIS into gas and then that creates CO2. No? Got the wrong one. Li3N. That's going to be a solid. And the whole point here is this is showing one lithium, two nitrogen, but over here you have three lithiums and one nitrogen. And that means there's Li here, there's an N and an N, and over here there's Li, 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 and an N. So the problem is we started with 2 nitrogens, but we only ended up with 1 over here. That can't happen. And we've only got 1 Li here, but we've got 3 here. That can't happen. So you have to set this up such that these balance, so that there's the same number of nitrogens on both sides and the same number of lithiums on both sides. So you kind of go by trial and error. But you can look first, you can start by just looking at the first one and going, there's 1 of these and 3 of these, so I need to put a 3 here. And that'll fix the lithium. And you look here and you got 2 of these and only 1 of these, so I'm going to need to put a 2 here. Then I'll have 2 nitrogens, and then the nitrogens will balance. But look, I've screwed up the lithium. Now I need 6 lithium, so I go over here and put a 6 here. I think that does it. 6 lithiums, 2 nitrogens, that'll do it. Now it's balanced. Do you see that? But did you notice I had to do it by trial and error? So these range from being very, very sticky and difficult to do to kind of straightforward and easy like I did there. A little bit of trial and error. I started with a 3 on lithium, but I had to go back and change it to a 6. So I mean to keep those kind of simple because iterations are just kind of nuts. There is a way to solve these analytically, but it requires matrix algebra, and we never teach that in the math section at the beginning of class. So there's balanced equation, so that one's balanced. TiCl4 and H2O. TiO2 and HCl. I'm going to leave off these are what we call states: solid state, gaseous state, solid state. I've just left those off of here. We don't need them for this. 1 Ti titanium, 1 titanium, 1 titanium, 4 Cls. I've only got 1 Cl here, so I'm going to start by trying this. So now I've got the Cls right. I have to balance the hydrogen. This says 4 hydrogens. I've got 2 here. If I put a 2 there, then now hydrogens are fixed. And then O2, this is telling me I have 2 oxygens, meaning 2 H2O means I have 1 of these and another 1 of these. 2 oxygens. Got 2 oxygens, and I look over here, there's 2 oxygens here, so I'm good. So I think that does it. 4 hydrogens, 4 chlorines, 1, 2. So that's balanced. You see the process? It is kind of trial and error. It makes it a little bit unwieldy, but like I said, I'll keep the balancing simple. It's just for the precipitation reactions in chapter 4, you end up having to balance some of them. Any of these get harder? Let me find a combustion reaction, and I'll show you why they're, well, do they have one here? But I'll do one of these. I'll do the sodium bicarbonate one. This one, NaHCO3. H2SO4. CO2, H2O. Na2SO4. CO2. Usually what makes this hard is when there's an atom, like I've got hydrogen here and hydrogen here. It's in two different places. That's usually what makes these hard. So generally you want to try to avoid doing those first. I wish we could just play in the hall. So I'm going to avoid doing hydrogen first, and if you get the other ones going, then the hydrogens will just work out. Let's start with carbon. Let's start with carbon. There's one carbon here, there's one carbon here. We're good. We've got hydrogen in two places and oxygen in two places. Oxygen in three places here, so this one might be hard. Let's start with the sodium. There's two sodiums here. I'm going to have to do this. Carbon is only in one place over there, so let's balance the carbon next. That'll make us have two carbons, so I have to do that. And then that gives us, let's see, we have a sulfur. There's one sulfur there, there's one sulfur there, that's good. So now we have to start dealing with the harder ones. 2 times 3, we've got 6 oxygens, plus 4 more oxygens, plus 2 more. We've got 12 oxygens on this side, 4 oxygens there, 1 more there, 5. Yeah, this one's harder than I would put on a test. So I guess I better just start trying. If I want 12 oxygens over here, got 4 there and 4 there, that's 8. I need to put a 4 here. That'll give me, so I've got 12 oxygens over here, and now I've got 12 over here. Putting that 4 there makes me have 8 hydrogens. 2 here, so I need to do this. Times 3 is 6, 7, 8. That's 8 hydrogens. Well, now I've got 3 sulfurs. That means I have to do this. I'm already lost. I don't even know what to do here. So I promise I'm not giving you any that complicated. You see why I hate iterations. It's just too much trial and error. But practice some of these. If they get too extensive, you can just stop. Because I won't do any too hard. The ones in the precipitation reactions go a little easier, but just practice some of those. I'll just go on to the next section because I feel like I'm not teaching chemistry when I do this. 3.2, okay. I have a couple in here. 16. Okay. This. I've tested you on this type of thing. Like if I said, what is the formula for calcium carbide? This is the formula for calcium carbide. It's got carbon. You call it carbide when it's in the ionic formula, and that's calcium. So I will give you these on the test. I won't say calcium carbide, I'll say CaC2. This one is saying, write a balanced chemical equation corresponding to this. Calcium carbide with water forms an aqueous solution of calcium hydroxide and acetylene gas, and then they tell you what acetylene is. Let me try that one, and then I'll move on from balancing. CaC2 with water, that's this. That makes, it makes calcium hydroxide. So instead of saying calcium hydroxide, I'll say this on a test. That's calcium hydroxide. Plus, what is it? Acetylene, okay. C2H2. one calcium, two carbons, and H2O. So we have two hydrogens here, and that two tells me I've got two more. So I need four hydrogens. So that'll make four hydrogens here. It makes two oxygens, and so that balances it. Can you see that that's balanced? One calcium, two carbons. This gives me four hydrogens. That gives me two hydrogens. And that gives me two hydrogens. So four hydrogens, so that balances. This gives me two oxygens. Oxygen is only here, so there's two of them, so that's two oxygens. So the whole thing's balanced. Something that simple is the type of thing I'd give you on a test. I don't want you sitting there trying to iterate something huge on a test. All right, and then the next section, 3.2. Let's see, I've got 19. So I've got 19 and 20 here. I'll do 20. Write a balanced equation. So setting this one up, titanium metal reacts with O2. Titanium metal reacts with O2. It's telling you to write a balanced chemical equation for the reaction. Again, what I would give you on a test, if I gave you that, you would just assume that's a combination reaction. I would say it's a combination reaction. I don't think they said that there. But it means you're going to have Li and oxygen together. What's the charge on lithium?
+1.
+1. And what's the charge on oxygen?
-2.
-2. That means you're going to need that. So this is more along the lines of what you're going to have to do on a test. So that's what lithium oxide is. So to balance this, I need a 2 there because I've got 2 of those. And I need 2 oxygens. So I have to do that. So now I have to back up and put 4 here, there. That's balanced. So if I said lithium and oxygen, does it say O2? Yeah, it does say O2. So that comes together to make lithium oxide. There it is balanced. The next one says silver oxide decomposes into silver metal and oxygen gas. This is oxygen gas. O2 is, you might see it written as molecular oxygen or just O2. Okay, decomposition, I gotta read it again. Silver oxide. Okay, silver has +1 and oxygen is 2, so I have to do that. Silver oxide becomes I put the S there. Ag is a metal. You could look at the periodic table and go, okay, there's Ag, it's a metal. I mentioned a couple of weeks ago that there's 4 types of compounds total in the universe. There's molecular compounds, ionic compounds, molecular compounds, and one more weird one, coordinate covalent compounds. But the 3 main ones are, I've talked about metals and nonmetals. When you have a metal and nonmetals together, you get what type of compound? Ionic. If it's only nonmetals, what is it?
Covalent.
Yes, covalent, the things we call molecules. You could say covalent or you could say molecular, they're kind of similar. There's one thing I've left out. I said you combine the two, you get ionic, just nonmetal, It's molecular or covalent. What is it when it's all metal? That's metallic. When you see something that says metallic, it means this, and it almost always means solid. So this is silver, what you think of that you'd have in jewelry or whatever. But usually we have little chips of it. Like when we added magnesium in lab the other day, we had what was clearly little metal chips that we were putting in. Remember that? So that was metallic magnesium, not ionic. This is ionic silver. This is metallic silver. And then O2 gas. So how do we make this balance? 2 here, 4 here. That does it. Right? 4 of those, and that makes 2 of those. So there it is, balanced. Okay, balancing chemical equation. All right, I'll go on to the next section. What else did I give you in that section? 21 and 22. I'm more likely to do this on a test. Just give it to you and say balance it or whatever. So this first one, is this decomposition, combination, or combustion? One thing becoming 2 things.
Decomposition.
Decomposition. One thing coming apart into 2 things. The next one, what is this?
Combustion.
Combustion. The hallmark of combustion is you always make CO2 and H2O. Among the reactants, it's going to be O2 every time, and then one of these hydrocarbon type molecules. So this is combustion. Here's 2 things becoming 1, so that's combination. Those are really easy. Decomposition and combination are just what you see here. This thing is decomposing into 2 things. This thing is coming together as one thing, that is combination. And then you can pull out your combustion reactions by seeing the H2O and the CO2 as products, and the O2 as a reactant, and then a hydrocarbon here. So this one, oh, did they cover that one? Oh, that's combustion again. And then this one is a combination. All right. We've done formula weights. The only other thing, okay, let's go back to limiting reactions, limiting reactant. That's down, all the way down, starting at 77. 77. All right, I guess I'll do 78. I might have already done this one. I bet I did do that one last time. The 0.5 and 0.5, I remember. 79, 80. I don't think I did this one. Okay, so there's your reaction. It's already balanced. 2 grams of NH3 is put in, 2.5 grams of O2. First question is, what is the limiting reactant? So let's do this. I guess I better write it. 4 H3 plus. And again, I'm not going to write these just because we don't need them for what we're doing, but 5O2 that makes 4 and O. 3 plus 6H2O. So there's our balanced reaction, and I will write in here 2.00 grams of this, NH3, 2.50. All right. Grams are mentioned here, so the first thing we need is the formula weights for these. We have N, we have 1 of them, we have H, we have 3 of them. 1.01. What is it for nitrogen? 1401. 3.03. So 17.04 grams per mole. And now we've got O2, it's just two oxygens. 2 times 16.00 equals 2.00 grams per mole. So it asks us NO2 and H2O as well. In B, how many grams of NO2 and how many grams of H2O? So we've got to do those as well. NO, one of those, 3 of those. What is 3 times 16? 32 plus 16, 42, 48. Gotta do that right. Well, 62.01 grams per mole.